The half-life of palladium-100 is 4 days. After 20 days, a sample of palladium-100 has been reduced to a mass of 5 milligrams. So this palladium, it's this palladium-100, its half-life is 4 days. That means every 4 days it cuts in half. It's really shrinking very quickly. So if you had, 1,000 grams of it sitting on your, in a dish on your lab table, then 4 days later it would be half of what it was, and then 4 days later it would halve again, and 4 days later it would keep cutting in half and half and half and half. That's what half-life means. So again, if you started with 1,000, then 4 days later it would be down to 500, and then 4 days later it would cut to 250. It doesn't go down 500 again. It's always half. Like part of it's dissipating into the atmosphere, down by half, and then 4 days later again it would cut in half down to 125, and then cut down to 62.5 4 days later, and then whatever half of that is, 31.25, I think, 4 days later. So it just keeps going down, 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 down. It'll eventually get super close to zero. It just keeps cutting in half every 4 days. So that's what we mean by the half-life. So it's the opposite of doubling. It's like a doubling problem, but it's the opposite. It's half. It's shrinking. This is decay. So whenever we have something growing or decaying, meaning it's multiplying or dividing by the same number each same period of time, that is exponential growth, or if it's going down, decay. And we use the formula y equals a times b to the t, meaning the t is in power. It's an exponent. That's why we call it exponential, because it's powerful, it's fast, things happen quick. So that's different than if it was just adding or subtracting. We said, hey, we've got a car, it's worth $12,000, but it's dropping by $1,000 each year. It goes down in value by $1,000 each year. That would be linear. That would be just y equals mx plus b. X would just be on the base level, not in the power. So if you're just subtracting or adding the same amount every period of time, that's linear. That's not very fast. But if you're multiplying or dividing the same number each same period of time, that's fast. That makes things explode or shrink super fast. And so in that case, you have an exponential equation to represent that behavior. T gets up in the power zone in those cases. That's how real life math and science works in these situations. Some things are linear when you're adding or subtracting the same number every time. Some things are exponential when you're multiplying or dividing the same number every time. Okay, so this is exponential. Our formula is y equals ab to the t, but specifically we know that it's halving. So this is going to be 0.5, a half, to the t divided by the half time. Like how long it takes to cut in half. That's how you always set up a half-life formula. Just like for doubling, we make the base 2 to the t divided by the doubling time. For halving, we make the base 0.5, that's half, to the t divided by the half time. And what is the half time? Every 4 days. So that's the half time. And whenever we use this form, so let's do that. A 0.5 to the t divided by 4, right? For 4 days, yeah, was the half-life. So there we go. There it works. You can see how, and A is the starting amount. whenever we use this formula, A will be the starting amount. See how this works? You see why we divide by that 4 there? Because if you let t equal, what's going to happen 4 days later? If you let t be 4 days later, then that will be a times 0.5 to the 4 over 4. That's 0.5 to the 1, which is just 0.5, which is half a. So 4 days later, that'll make it half of a. That's perfect. That's exactly what that formula should do. You see why we divide by the half time? And what if it's 8? What if that t is 8? Then that'll be 0.5 to the 8 divided by 4. 0.5 to the 2. That's 0.5 times 0.5. That'll come out 0.25. See, that'll multiply 0.5 twice because 8 days later it would have and half again. It's going to be 0.5 and 0.5 twice, which is 0.25. See how that formula's working perfectly? So that's our formula. A is the starting amount. Now we're ready to start solving stuff. What are they saying to us? They're saying after 20 days, so that means when t is 20, it was reduced to 5 milligrams. The amount was 5 milligrams. So 5 milligrams when the t is 20, right? Wasn't that 20? Yeah, 20 days later, the mass was 5 milligrams. So 20 days later, put in the t to be 20. The y became 5. So now we can solve for a, which is the initial or starting amount. So let's solve this equation for a. This is going to be 0.5 to the 5. And 0.5 to the 5, let's see what it is. It is 0.03125. All right, so now we're going to solve that equation for A. Divide by 0.03125. Cancel this out. So A will equal 5 divided by the answer. I'm getting 160. So A is 160. So that means that's the starting amount. That's the first answer. So the starting amount of that palladium stuff must have been 160 milligrams. I guess this is all in milligrams. Milligrams of it. Must have been 160. So now we're ready for part 2. So in part 2, so now we've got the formula. Y equals A times 0.5 to the t over, what was it? I already forget. Over 4. It cuts in half every 4 days. Right? Cuts in half every 4 days, right? And now we know what the A is. We can pop that in right there. It's 160. So there we go. There's our formula. We can answer their last question. And what is their last question? It is, what is the mass 7 weeks after the start? 7 weeks after the start. Seven weeks after the start. So what do? Do we just take the t? Do we just plug in t equals 7 and find the answer? Almost, but you know better than that, huh? What's wrong with the 7? The 7 is weeks, and we've been working in days up to now, haven't we? We can't change our time units. It's been all days. It's been days here and days here. So all of our formula has been in terms of days. We can't change our time units, so we got to stick with days. So we got to take 7 weeks times 7 days in a week is 49 days. 7 weeks is 49 days. So now we'll plug in that. Y equals 160. 0.5 So take that 49 and plug it in right there. 49 over 4, that's 160.5. 49 divided by 4, I'm getting 12.25. All right, hit the buttons on your calculator. And I'm getting 0.0328475. 8475, and it goes on and on and on. And that's milligrams of the palladium. So the palladium is almost down to nothing, right? It started out, what did it start at 160 milligrams on the table, 160 milligrams here, and then it just went down to 0.03 after 7 weeks. It's just cutting in half every 4 days. It just kept cutting in half and half and half and half and half, and got really, really small after 7 weeks. There we go.